this is pretty easy, this factoring for this section. It just has coefficients of 1 in front of the x squared. So, you probably can see the combinations that are going to work for you when you factor. The reason I want to teach you this box method is this box method works no matter how many, if you've got 3 terms or 2 terms, and it's especially helpful when this first term has a coefficient of something other than 1. So we'll work with the easy ones today, and then when we come back next week, we'll work with harder ones. All right, here's how the box method works. You start by drawing a box. All right. And first spot goes the first term x squared. Diagonal from it goes the fact that this is a plus 20. Okay. Then over here, you're going to do this little chart. Here we're looking for what are the factors that when you multiply to give you 20, but when you add the factors, you get negative 9. So factors of 20 might be, for example, 1 and 20. But when I add 1 and 20, I get 21, which is not negative 9, correct? If I did 4 and 5, that gives me positive 9. So then my factors that I really want to use are what? Negative 4 and negative 5. Okay. So what we do now is in these spots, and these are interchangeable. It doesn't matter which one you put in either of these spots. You'll get the same answer no matter what. One of them is negative 4x. You put the variable there. Okay. And over here, you put your other factor with an x, negative 5x. Okay. All right, we're looking up. Between negative 4x and positive 20, what's a common factor that they both have? 4. But because this one is negative, we're going to make it negative 4 that we're pulling out. So the sign of this value up here is determined by the sign of this square. Okay? Keep going up. Between x squared and negative 5x, what's our common factor I can pull out? Okay? And now we go right to left. Between x squared and negative 4x, what's in common? And between negative 5x and 20, what's common? Is it negative 5 or positive? Negative, because it's whatever. It's the closest one to the side. So your factors are x minus 4, x minus 5. Works always and forever. 2 terms or 3 terms? Yes. Yeah, not if we have 4 terms. We use a different method for 4 terms, and only for squared. Okay? Yes. What are my factors of 20 that when I multiply them together give me 20, but when I add them together I get negative 9? Okay? All right, here we go. So what goes here? X squared. What goes here? Okay. So we want to get a product of negative 12, but we want to get a sum of the factors of 3. So what are your factors of negative 12? Well, 4 and 3 gives me 7. And it also doesn't give me negative 12. So you got to remember, how much? Okay, so 2 and 6 is positive. So you could do maybe negative 6 and positive 2, but that gives me negative 4. Right? I could do negative 1 and 12, but that gives me 11. Right? And if I flip-flopped them, then I'd get 1 and negative 12, well, that would give me negative 11, right? So in this case, I don't have any factors. If I don't have any factors that works, then it's not factorable. So not all of these are going to work out. What would you have used in this case? Do you remember from last year what you would have used to come up? The quadratic formula. Do you remember the quadratic formula from last year? You can. You can. Perfect. Okay. There you go. All right. Here we go. We put the n squared here. We put the 9 here. What are our factors of 9 that give me -3? Well, factors of 9 are 3 and 3, which are 6. -3, -3, which are -6. 9 and 1, which are 10. Guess what? Not factorable. Okay. All right. This is q squared plus 0q minus 100. Does that make sense? So in my box, I put q squared here and -100 here. Would you agree? And over here, what are my factors of -100 that give me 0? -10 and +10. So -10q, +10q. Working up, what do I pull out of this right column? -10. What do I pull out of the left column? What do I pull out of the top row? What do I pull out of the bottom row? Q plus 10 and Q minus 10. Anybody remember what these are called? Q plus 10 and Q minus 10? Where everything is the same, but one sign is different? They're called conjugates. You're going to see that word again. Opposites. They're called opposites, right? So you got to remember, this is an example of the difference of perfect squares. You really need to know this and recognize this as a really important factorable problem. Because not only are you going to use it in algebra, but you're going to use it in calculus when we get to trig problems. So you want to be able to see if the first term and the last term are both perfect squares, and you've got a subtraction sign in between, you've got the difference of perfect squares, and so it's first term minus last term and first term plus the last term. Yes? But if you don't see it, it'll work. Okay? All right. Y squared, 64. What are my factors of 64 that give me 16 when I add? 8y and 8y. So moving up, my right column gives me a common factor of, and my left column a common factor of y, and my top row a common factor of y, and my bottom row a common factor of. This is y plus 8 times y plus 8. If you leave it like that, I'll count it wrong, or I'll take a point off, because we always want it simplified. All right, Mackenzie, go for it. Correct. Which is why when you give me, and you try and FOIL this out, and you give me y squared plus 64, I bang my head on the wall. Because you guys are pulling them squared in, and you can't ever pull a squared exponent in when you're adding or subtracting, right? We really started with y squared plus 64 plus 16y plus 64. Okay, so it's not this. This is what I'm looking at. Are we good? All right. W squared, 81. What do you think your factors of 81 are? That give me -18. -9 and -9. Agreeable? So I'm going to pull out a -9 here, a W, and a -9. So W minus 9, quantity squared. All right, what's the difference between this problem and the new problem? No, this had two variables in it. What is this one saying versus this one? What's different in the way it's written? Maggie? Y equals. This is an equation. First problems weren't an equation. All you could do is factor. If I want the zeros, I'm looking for the x-intercepts. So if I want the x-intercept, then that's when what equals 0? So think about a graph. Where do your x-intercepts fall? On the x-axis. So what's going to be 0? The y, which is why when I ask you to find the zeros, you set y equal to 0. So 0 is equal to x squared plus 5x minus 14. So step 1, set the equation equal to 0. And step 2, factor. Okay? So this one's going to factor to x plus 7 and x minus 2 equals 0. So solve. What does x equal? What's it going to equal? This is kind of what we've been doing with some of these methods. Kate? Positive 2. Negative 7 and positive 2. So I have a question. If y is equal to x squared plus 5x minus 14, what is that the graph of? What is that graph going to look like? It's a parabola. All right? Where is a parabola crossing the x-axis? At negative 7, positive 2. How does that parabola open? Up. So it's doing something like that. So all these times you've been working with parabolas and you didn't know it. And we just transformed it from a standard form into, what did we just make it? X-intercept form. So you can take a problem from standard form and convert it into an intercept form if it's factorable. Okay? All right. Here the factors are x minus what? What are your factors of negative 30 that give you negative 7? X squared and negative 30. Factors of negative 30 that give me negative 7. So we might say negative 10 and 3. Negative 10x and 3x. So I can pull out a negative 10, an x and a 3. So x minus 10 and x plus 3 equals 0. X is equal to 10 and negative 3. Are we good? Pretty easy lesson? Okay. All right. X squared and 25. Factors of 25 that give me 10 are, only I want negative 10, negative 5 and negative 5. So negative 5x and negative 5x. I can pull out a negative 5 and a negative 5. So x minus 5 quantity squared equals 0, which means x is just going to equal what? 5. Right. How'd we do? So use the box method when you're doing the problems from this lesson. For the next 2 lessons, I think the next lessons got coefficients other than 1 in front. Okay? Adays? What's the quiz up to? Okay.